Hi again, grade 9s. So last time we looked at chords in a circle, understanding what they are. Now this time we're going to take a look at trying to solve problems using chords in a circle, or using the properties of chords in a circle. So let's take a look at this example here. So it says determining the measure of angles in a triangle. Okay, so point O is the center of a circle. So here's point O, that's my center of the circle, and line OC bisects chord AB. So here's line OC, and here's my chord AB. So that's my chord, and this line bisects it. And so now, what we're told, when it bisects something, it's dividing it in half, and that was one of the chord properties we looked at last time. So we're told that this angle here is 33 degrees. So now what we need to understand is that we actually have one isosceles triangle. And so if we understand that, we know that triangle OAB, so OAB, so OAB, it is an isosceles triangle. And an isosceles triangle, I hope I'm spelling isosceles right. An isosceles triangle has two equal sides right here, and these would be it right there. Okay, and in an isosceles triangle, it would have two equal angles. So this angle here, we'll call it angle OAB, is equal to angle OBA. So this angle right here. So this angle and this angle are equal to each other. Or we could simply say angle A is equal to angle B. Okay, so now if we understand that, we know that angle A is equal to 33 degrees. So then angle B has to equal 33 degrees. So we found this already. That's 33 degrees. So now the question says determine the values of x and y. So x was over here, which was angle B, that's 33 degrees. Now we have this one over here to find, okay, which is y. Now understanding this is actually pretty simple, because here if we take a look, we have a right angle triangle. And we know it's going to be a right angle because a line coming from the center of the circle and it bisects a chord has to make this perpendicular. If it's perpendicular, that means that's 90 degrees over here. If this is 33, well then we can easily find the missing angle by just simply doing this. If there's y, I know I have 180 degrees total, and then I'll subtract what I do know, 33 plus 90. Okay, 33 plus 90, that's going to give me 123. Subtract that from 180. So then angle y, or the measure of y, is simply 57 degrees. So that means this angle right there is 57 degrees. So that wasn't too difficult, fairly easy to follow, using the chord properties. So now let's take a look at this one. This one is slightly complex, a little more complex, but still simple as long as we can understand what's happening. So once again, we're told point O is the center of a circle. So there's point O right there. That's the center. Okay. AB is a diameter with length 26 centimeters. So here we go. Here's A, here's B. It passes through the center. So when a chord passes through, we call that the diameter. Okay, so understand that. It says CD is a chord that is 10 centimeters from the center of the circle. Okay, so here's chord CD. And we're told that it is 10 centimeters away from the center of the circle. So it's 10 centimeters away. It's not saying that CD has a length of 10 centimeters. just means that it's 10 centimeters away from the center. Now the question asks, what is the length of chord CD? So here's chord CD. We want to know what is the entire length of that chord. Give the answer to the nearest tenth. Now, let's take a look at what we or how we can do this. So first of all, if I know that AB is a diameter, and if half of a diameter, okay, is what we call the radius. So if I take 26, divide it in half, I'll get 13 centimeters. Now, so from here to here, that's the radius. That's 13 centimeters. So maybe I'll do this in red. And then now here also, that's from the center. The center's right there. That's also the radius. If I said the radius up here was 13 centimeters, well, then the radius here is also 13 centimeters. So now I think you could probably see what kind of math we're going to have to do. I'll just outline it in red. And I know over here that this is perpendicular, so I know that's going to be 90 degrees. So I know this here is 13, this is 10. I don't know what this is. But if I find out that, I also find out this, and I can combine these two together, and then I have this length, CD, which is what the question is asking for. But I have to find out what half of it is first. And I can do that by using the Pythagorean theorem. So for our purposes, remember Pythagorean theorem was a squared plus b squared equals c squared. And remember, c always represents a hypotenuse. Hypotenuse is always across from the right angle. Here's the right angle. There's the hypotenuse. So I'm told it's 13. So I'll just say that c is 13. And I'll just say, put c there. And this I'll say is a. That's my unknown. And this I'll say is b, what I do know over here. So a, I don't know what a is, so I'll leave it as a, say a squared. B, I'm told is 10, so that's 10 squared. Now I can just simply do this math over here. A squared, we don't know what it is. 10 squared, well that's 100. 13 squared is 169. Okay, and now we should know what to do from here. So a squared, I have to get rid of the 100. So I'm going to go 100 minus 100, oops, equal to 169 minus 100. Simple algebra. These will cancel out. Now I'm left with a squared equals 69. I got to get the a by itself. In order to do that, I got to take the square root. What I do to one side, do to the other. So then this will be a. If I do this on my calculator, I'll get something like 8.307. But it wants it to the nearest tenth. So that to the nearest tenth, we'll say a is approximately equal to 8.3. So now this here is 8.3, which means this here is also 8.3. So if I want to find the length of CD, I'm just simply going to add the two together. So I'll go 8.3 plus 8.3, and I'm going to get 16.6. So the length of CD, get a word problem, needs a word answer. The length of CD is 16.6 centimeters to the nearest tenth. Okay, I think that was relatively straightforward, a little bit more complex, but I think we got it. Now, let's take a look at this one. Now, to do this one, involves a little bit more of a thinking process on our parts. Let's take a look at the question. It says a horizontal pipe has a circular cross section. So this is a circle, it's a cross section, okay, with center O. So there's the center, we'll do this in red. Okay, its radius is 20 centimeters. So here's the radius. So from here to here is 20 centimeters. Water fills less than half of the pipe. The surface of the water, AB, is 24 centimeters wide. So it's here in blue. Well, that represents the water. Okay, so it fills less than half of it. The surface of the water is 24 centimeters wide. So here's the surface of the water. So from here to here, well, we're told that it is 24 centimeters. So from there to there. So that means line AB is 24 centimeters. Determine the maximum depth of the water, which is CD. So that's what we have to find. We have to find what it is from here to here. So now, let's think about what we do know. Okay, so we know that this is the radius, 20 centimeters. So if that's the radius, this also would be the radius. So that also would be 20 centimeters. So from here all the way to there, well, that's also 20 centimeters. But that's not what we're being asked to find. We want to find out is just this little section, and maybe I'll do this part in black. So we want to find out that section, which is CD. Okay, so now if we understand that this is the center, and if this is the chord, from the center, it's going to the midpoint of the chord, it's going to divide it in half, perpendicular, so that means that this will be the same length. Okay, so how are we going to do this? So if we know that from here all the way to here is 24 centimeters, then that means this must be 12 centimeters. Okay, and that means this also is 12 centimeters. Okay, so now I think we have enough information to start putting together what we know. Okay, so we know that O to D, okay, so line OD is equal to 20 centimeters. We want to find what, oh sorry, I made a mistake. My mistake. OD is, no, I'm right, sorry, OD is 20 centimeters. We don't know what O to C is. So O to C, that's our unknown. Okay. But we do know that in order to find CD, right there, in order to find CD, we're going to have to subtract OD and OC. Because we just want to find this section. Maybe I'll do this part in green. We just want to find the length of that. And that is a part of this entire line segment. Okay, so in order to do this, we're going to have to use the Pythagorean theorem. So why are we going to use the Pythagorean theorem? Let me actually erase this because I don't know what this is. I don't know what OC is. So basically from here to here, that's my unknown. I don't know what that is. So I'll use the Pythagorean theorem. Okay, and if I'm going to use the Pythagorean theorem, okay, let's say I'll call this side A, and I'll call this side B, and this side obviously is going to be C because it's the hypotenuse. So then my formula, A squared plus B squared equals C squared. Okay, so A I know is 12, so we'll square that. B I don't know what it is, so I'll leave it as B. C is 20, and we're going to square that. Okay, so let's just do the math that we know how to do. Okay, so 12 squared is going to be 144 plus B squared. 20 squared is, well, that's 400. Okay, and now all I have to do is just get rid of 144 on one side. Okay, just simple algebra. And what I do to one side, do to the other. So 400 minus 144. These cancel out, leaves me with B squared 400 minus 144, well, that's going to give me 256. Now I have to take the square root of both sides to isolate the variable. And here, 256, square root of that is 16. So what does B represent? B represents OC. So OC is equal to 16 centimeters. But that's not what we want to find. We want to find the length of CD right there. And we said this is how we're going to do it. In order to find CD, we're going to go CD, we're going to subtract OD and OC. OD, we're told, is 20 centimeters. OC, we just found out to be 16 centimeters. And if we subtract the two, we get 4 centimeters. So now we've answered the question. The depth of the water is 4 centimeters. Okay, and there we go. So hopefully that will help us to do some problem solving using chords of